I'm Bjorn Strand,
I'm Blake Turnus.
and this is our Advanced Embedded project.
Well, we decided to port the mobile game 2048 to our board. We made a start menu, which is a little bit different than the original game. Oh, that's it. So the original game plays where you slide tiles and like tiles combine, and the goal is to get another double, get each tile to combine up to the number 2048. And so what we did is we made the board and the game similar to the point where like tiles will combine and add up to 2048, and once you get 2048 you win the game. So by sliding tiles up, right, or left, tiles will combine and you try and get the highest score you can.
Also, during game, you can pause it using the pause button, which brings up a pause menu, which has the options to resume, restart, or go to the main menu. So as you can see, if you hit resume, you would continue with the same game you had before. If you hit restart, it will start clean, and so you can start over again if you mess up. And then main menu will take you back to the main menu. On the main menu, there's also a settings option, which lets you choose the size of the board. So the default is 4x4, but you can also choose a 5x5 board, which, as you can see, makes the tiles a little bit smaller. And it makes it a little bit easier because you have more space to work with. Also, you can also go to settings and choose a 6x6 board, which will be even smaller tiles, and then will give you even more space to work with, making it a little bit easier. But that is basically how the game works. There is a win screen when you do get to 2048, and we're going to reprogram it real quick just to show you that without having to play through a whole game. So we now have a new game, or a new code programmed on that spawns slightly larger tiles, so it'll be quicker. As you can see, tiles still combine as they would if you actually played to this point. Skip some of this to make it quicker. So we have two 1024 tiles, and we combine them to 2048. We get game over, final score 2048. You have the option to restart or go back to the main menu. So restart or go back to the main menu. So when we were working on this project, one of the most difficult things to deal with was animations. It was a combination of the graphics driver on the board is pretty inefficient and draws things slowly, and it was also difficult to have multiple objects moving in parallel, as opposed to, say, moving one tile from A to B and then moving the second tile from A to B and then moving the third tile from A to B. So in order to have, say, 3 or 4 tiles moving at the same time, we created an array of structures where each structure represents a motion vector for the tile, and then we go through the structures and increment each structure one movement at a time, so that it looks like all the tiles are moving at the same time instead of moving each tile and then moving on to the next one. The other issue was frame rate. So what happens is, because we draw objects one at a time, in order to get consistent motion, you have to take into account how many objects are moving. So if you're moving one object, it will move at one speed, but if you're moving 2, 3, 4, or 5 objects, it will be slower for each object you add. We figured out that the speed of this drawing is linear, so the amount of time it takes to draw an object directly correlates to the number of objects you have to draw. So in order to make animations consistent, meaning when moving one tile, it's not going to be way faster than moving 10 tiles, we've used an adaptive frame rate. So up here, we have a timeline. So we wanted all our tiles to move in under 1/4 of a second. So how we did this was, if there's one moving object, it would move in, say, 3 pixel increments. So This is position 1, 2, 3, 4, 5, 6, and 7. So as you can see, a total of 7 objects needed to be drawn and erased in order to move that object from A to B. If there's 2 moving objects, we would have it move by double the amount of pixels, so in this case 6, meaning that your object would move from here to here to here to here. So if you have 2 objects, as you can see, we only need to draw and erase 8 objects instead of double the amount of objects we have to draw and erase up here, meaning that the timing is almost the same when moving 2 objects as it is for moving 1 object.